Joe Holbrook here, the cloud tech guy. I want to reach out and talk about the mini bootcamp session number 7 around Ethereum basics. This is specifically for the Blockchain Solutions Architect exam. Let's go ahead and discuss more about Ethereum. Now, when it comes to Ethereum, we're going to cover basically an overview and then talk about smart contracts, mainly in this specific session. Got some review questions and some other resources to study as well. Now, Ethereum, just to confirm, is really the most widely used open source blockchain-based distributed computing application platform. Now, a lot of people generally in the general public, the media, they confuse Ethereum as more of a cryptocurrency and not a platform. Ethereum is really a platform, and I'll talk about how gas and ether sort of fall into this. But the main thing to really know is that it's a platform. It's not, it's not a cryptocurrency per se. Does it have a token so that you could use the platform? Absolutely. However, Ethereum itself is actually the platform. And this is an open source platform. And once again, you have projects that are developed on it. Any developer or organization can use this open source base essentially, so that you can develop your own private instances essentially. Now, basically, the main goal is to implement smart contract functionality. And again, smart contracts are what? They're basically also known as chain code, especially if you're looking at Hyperledger. But when it comes to chain code, smart contracts, it's basically a program that is, snippets of code that is essentially going to have rules and decision points, and that'll define how transactions are processed in the blockchain. Basically, they're going to be published directly to the blockchain, and those will be automated essentially. And assuming that everyone follows the rules, that smart contract will be, initiated essentially. Basically, it offers a decentralized EVM platform. It's known as the Ethereum Virtual Machine. This was actually developed by Vitalik Buterin. He initiated the project essentially. It was developed by a group of numerous developers, of course, but it was Vitalik Buterin's sort of jumping out there with the project that got it going. And it went live on July 30th, 2015. And for the exam, you may want to know the year 2015, just a hint there. Now, some terms I want to just clarify. Generally, in Ethereum, a lot of people think Ethereum is a cryptocurrency. Well, technically, it's not. Ethereum's a platform, and Ether is the token that is essentially utilized on the platform. This is how the usage for the EVMs, the platforms, essentially are utilized, and you use Ether to pay for that utilization. This gives rewards essentially, also transaction fees essentially to the miners in the blockchain. Now, again, Ethereum's a platform. Ether is the token. Now, the total supply of Ether and its rate of issuance was decided by donations in 2014, which was a pre-sale of the currency or the tokens is really how it should be stated. There was 60 million Ether created, 12 million, 20% went to the development fund. And when it comes to creating blocks, every block, 5 ethers are created. So about every 15 seconds. There's 2 to 3 ethers that are also sent as uncles, as they're known, to another miner. For the exam, you may want to know 5 ethers are created with every block. That may be a hint. Okay. Let's clarify. Ethereum has 4 main components. It has nodes, it has an EVM, smart contracts, and distributed apps. The EVM is built into the software running on the Ethereum platform. Let's go ahead and rephrase that. The Ethereum virtual machine is built into the software running on the Ethereum protocol. It's going to execute the smart contracts. Basically, remember, the smart contracts are programs written in Solidity. Now, the EVM is contained in the full nodes of the network itself, inside of which executes these user-written programs, which are what? This is your smart contracts. Now, also note a DApp is what? It's going to be a combination, a collection of essentially smart contracts that work together to form essentially an application. Now, these EVMs are also Turing complete as well. The EVM code is the programming language in which accounts on the Ethereum blockchain can contain code. This code essentially is associated with an account and is executed every time a message is sent to that account. And basically, when that request, that transaction initiation occurs, that smart contract's kicked off essentially. There's of course some processes that happen to utilize that platform. Now, again, that code is running on the EVM node. Now, Ethereum uses what's called gas. This is a measurement that's roughly equivalent to the computational steps for Ethereum. Basically, it's an estimate of how much work that EVM has to do. Now, gas is also not really tied to the price of Ether essentially at the time that it's running. It's basically an estimate based on computational steps. And I have a separate module that covers gas as well, because that's important to understand. Every transaction is required to include a gas limit. And of course, that's the fee that the user that's trying to include that transaction in the blockchain is willing to pay the miners, right? Every operation has a gas expenditure on an EVM. And that's essentially writing to the blockchain. Now, if you're just going to use a blockchain explorer, there's no EVM cost required for that, for example. Now, the Ethereum blockchain, right, as we know, is going to run on the nodes, and those nodes are running on that EVM, right? That EVM is running on the nodes, right? And that code is running essentially in that EVM, which is essentially a transaction-based state machine. Now, in CS, right, that state machine is going to take inputs, and based on those inputs, will transition to a new state. And essentially, one input will lead to another, right? Now, when it comes to a genesis state, right, that's the beginning state, and then it transitions to the final state, right? It starts off on the blockchain, right, with the first block, and then what happens is that those transactions will get appended to the blockchain. And here's an example of a transaction. Basically, that transaction will be validated through what's called mining. And Ethereum at the time of writing is still using proof of work. However, there is going to be essentially a split, a fork down the road, a new blockchain created when it goes to a proof of stake algorithm. Now let's discuss smart contracts. Now, smart contract is a term used to describe computer program code that is going to facilitate essentially an agreement. It could be a contract, right? Now, the entire process is automated, and therefore there's no intermediaries like attorneys, accountants saying, oh, or bankers that are saying, okay, this user provided the right amount of funds. Well, that smart contract is going to determine that based on computer logic. And so this contract will basically be initiated by a user or some kind of other application. Approach could be a client app, whatever, and it'll be kicked off essentially and automated. And if it meets the conditions, it proceeds. If it doesn't, it doesn't proceed. Now, smart contracts provide a lot of great benefits. Now, when it comes to smart contracts, it provides autonomy, trust, also backup, safety, speed, savings, and accuracy. Now, when it comes to autonomy, these again can be developed by anyone. Anyone can go ahead and create these and deploy these on the blockchain. Trust is pretty straightforward, but backup. One of the things to note when it comes to backup is that those smart contracts, when they're deployed, they're basically a permanent record on the blockchain. And this, of course, provides some challenges, especially if you're in a DevOps environment or agile, and you're trying to use some specific best practices around managing continuous improvement and deployment. But again, it is a fully deployed on the blockchain. Every node will, of course, be aware of the smart contract. It does provide auditing, accountability, for example. Now, when it comes to, let's say, speed or savings, right? A lot of that is dependent on, what you're trying to accomplish. One of the things I like to point out is that the blockchain is not exactly going to be quicker than, let's say, the Visa network. And Ethereum is permissionless, and therefore, in most cases, it's probably going to be slower than a permission blockchain. That, again, is up to you to decide what makes sense. Now, accuracy could be certainly, validated in the sense that if you don't have humans making the decisions or making entries, that could certainly increase the accuracy, reduce human error, right? And here's a comparison of traditional contracts and a smart contract. Basically, traditional contracts are a manual process. They could be costly. You may need attorneys. Smart contracts are pretty quick to run. They're very cost effective. And you may not need lawyers as well to provide any kind of legal advice around these. Now, basically, smart contracts, they define the rules and the penalties around an agreement. And it's very similar to a traditional contract. And that's where the contract term sort of came from, is that this application, or the snippet of code essentially is going to enforce obligations. So basically, if Sally doesn't pay $12.80 to Frank, then that purchase won't be consummated. If Sally does, then that purchase will be consummated essentially. Basically, when you have a collection of smart contracts, they make up what is known as a decentralized app. When it comes to smart contracts, there's functions that are required in a smart contract. You have a constructor function and a fallback function. Now, the constructor function is called once. Basically, it's initiated at initiation of the smart contract. And the fallback is used when there's a reason essentially to be invoked. It could be that if something is not correct, or there's an issue with the smart contract itself, then this function could be called. And also, too, a quick note is that ether sent to the smart contract could also be rejected. Couple other notes about smart contracts. Again, a lot of things to cover. For time purposes, I won't take a lot of time. Feel free to review the slides, and prepare accordingly. But basically, smart contracts, they provide better security than traditional contracts. They could also cut costs. They're basically going to run on what's called an EVM. We're going to talk about that in a minute. And the dApps are basically a collection of smart contracts. Now, when it comes to enforcement, basically, anytime you modify a contract, basically, again, that code requires a blockchain user to send requests to the code. Basically, again, this could kick off basically a process to determine whether or not this request is fulfilled or not. Basically, a traditional database uses an enforce stored procedure, very similar to that. And this approach is also known as predefined rules. Now, when it comes to legal enforcement, this is again a little bit tricky. A lot of times, smart contracts or chain code, they're considered illegal, process, and the reality is that there's nothing legal about them. And in most cases, most jurisdictions, they're not even legally enforceable. But with that said, could be used as evidence. I like to compare a smart contract to like a vending machine. If you put in the required funds, you get the drinks. If you don't, then you don't get the drink, right? Pretty straightforward there. And here's an example of a workflow for a smart contract. As you can see on the left-hand side, you have your Ethereum account. That's your wallet. And basically your address, balance, and then you have the code and also the state, for example. Now, again, you can see the code snippets there, the address where the balance is coming from, right? Now, on the right side, you have the workflow. Basically, you have a predefined contract. You have events, basically the triggers that, if the funds are sent, it causes a trigger, and then it'll execute and then transfer the value from the buyer to the seller, for example. And if everything works out and basically the seller is, their conditions are met, the buyer is then allowed to purchase whatever they're trying to purchase, for example, right? And this could be, this settlement can happen on-chain or off-chain. You could certainly use on the Ethereum blockchain off-chain approaches. Like, for example, you want to tie into a specific API interface or use another database service or update it to another record. A little bit more behind that from a development standpoint, but a lot of things could be done. So it could be done on-chain, which is on the blockchain itself. So the assets could be transferred that way, or it could be done off-chain. Let's go ahead and test our knowledge. When it comes to Ethereum, right, to be able to utilize the Ethereum blockchain, every operation has a cost. Is that true or false? And that would be true. Now, just keep in mind that that's more for writing a transaction to the blockchain, not so much to go to like the Explorer and view the transaction. That is no cost. Now, EVMs run code in what programming language? That is Solidity. Now, can you write client apps that are in Node.js or PHP or Python? Depending on your skills, certainly you could. And then, again, you'd have to interface with the Ethereum blockchain, which is going to use Solidity. Now, there's 4 components. Basically, you want to know which one is not a component. You have a virtual machine, which is an EVM. You have smart contracts. You have dApps. And then the nodes. Now, gas is not a component. It's basically a required function or feature to utilize a blockchain. So think of it from that perspective. Now, if you're taking the exam, this is the link to do that. The cost of the exam is $300. There is also another study guide you purchase for, I believe, $40 or so, or $39, somewhere in there, whatever the price is when you go look at it. I have some practice questions on Udemy. The link is there. There'll also be a boot camp that's being released here very shortly as well. And here's some other links as well. I've also been teaching Hyperledger on O'Reilly Safari. I encourage you to go check out that link and join the sessions if you so choose. The cost is very affordable, considering the value you get for an 8-hour course as part of your subscription. And thank you again for joining. I do wish you luck on your exam. And if there's any questions or comments, please do reach out via YouTube or LinkedIn.